Well, hello there. Unfortunately, Nola is sick again, so here we go. Um, we did go to the Children's Museum this weekend, which was really interesting because all of the artwork was hung up on refrigerators. That was fun. So there will be some more jokes on the second page video because you're waiting for those jokes. Today should be pretty easy. Just gonna be doing some solving. Tomorrow or Tuesday, I guess, I will be giving you guys the review for the test, and then on block day we'll have a little bit of time for review, and then the test will be the rest of the class. So, but a little bit of solving here. We're going to make sure we check our answers because there will be some extraneous solutions every once in a while. So, I want to make sure that we find those boogers when we have them. So, let's see what's going on with my Zoom here. Why isn't it working? There we go. All right, so I think most of the time, so we're wanting to isolate the term with the root. So what we mean by that is term with the root business is we want this to be by itself. So I want all the other stuff to be on the other side of the equal sign. That way when we go to get rid of that root, when we square or cube or whatever, that it's the side with the root is simpler. So it definitely needs to be your first step is to isolate that root. So we're going to add 8 to both sides right off the bat. Let's see. So it gives me the square root of 4 minus 3x equals x plus 8. And so we want to unsquare root, and so what we're going to do is we're going to square both sides. And the whole point of doing that is to get rid of the square root. So on the left side, we just get 4 minus 3x. But we got to be really careful. We don't do that stupid mistake that I think we can just drop that in because that's definitely going to be wrong. So we're going to go ahead and say that means we're going to write x plus 8 twice. I don't know why I'm writing it over there. Which, when you go through the FOIL there, you get x squared plus 16x plus 64. So 4 minus 3x equals that. And then now that since we have a quadratic, we're going to move everything to the side where the quadratic is. So we can solve that quadratic. So I'm going to subtract 4. I'm going to add 3x. So we get 0 equals x squared plus 19x plus 60. And we got a little bit of easy AC here. So what are factors of 60 that add to be 19? Was that 4 and 15? So x plus 15, x plus 4. So that means that x equals negative 15 and x equals negative 4. So some things I've noticed, don't lose these zeros. It's important that you keep everything there because it is an equation. So I've just noticed some students dropping those off, and that's not okay. So there's our 2 answers. Let's see if they both work. We saw some extraneous solutions. It's back in section 4.3 with those rational functions. When the denominator became 0, there was create an extraneous situation. This is going to be a different issue here with the extraneous problems or extraneous solutions, and we'll cover that. And so I'll make sure that always use that original equation. So negative 4 minus 3. Let's do the negative 15 first. What's going on with my handwriting right now? Sorry. And then close that radical. Minus 8 is supposed to equal negative 15. So we got simplify. So 4, let's do plus 45 minus 8 equals negative 15. So the square root of 49 minus 8 equals negative 15. And that'd be 7 minus 8 equals negative 15. which would be negative 1. And that does not equal negative 15. So negative 15 does not work. Let's check negative 4. So we have 4 minus 3 times negative 4 minus 8 equals negative 15. So we got 4 plus 12. So that'd be the square root of 16. Oops, I wrote negative 15 there. Ha! Look at me go. Good job, Matt. It should not be a negative 15. That should be a negative 4, because that's what x is. There's an easy mistake to make. And so here we get 4 minus 8 equals negative 4, which it sure does. So, and a few of you were not labeling your answers extraneous. You had said that they didn't work, so you'd put like a check or an X mark by them, but you didn't label them as extraneous. You do need to do that, just that last little step. So make sure that as you're doing that, notice how I didn't solve ever. I always was just simplifying the left side until I could tell if it was true or not. So something that's different, right? So we get an untrue answer here. So negative 1 does not equal negative 15. So it's not like the last extraneous solutions we had where the answer we knew was wrong because the denominator was 0. So just a false statement. And here we have a true statement. So definitely could have problems with multiple answers that do work. We definitely have problems with one answer that works, one answer that doesn't. If both your answers are extraneous, good chance you're messing something up. So make sure you check in that. So the next problem. So this one looks a little bit more complex. We have multiple radicals here, and so the idea is that we do not want to square it as it is right now, because putting parentheses around this and having to write it twice and FOIL that would be very difficult. So what we're going to do first off is kind of get it so there's just one radical on one side kind of by itself, and then we'll have a radical with another number together. So first thing we do is add the one radical to the other side. And so we end up with the square root of 3x minus 4, or plus 4. So it's kind of isolating one of the radicals. It doesn't really matter what order you write this in. 2 plus square root of 2x minus 4. And so now we want to square both sides, because that's going to get rid of this radical here. So that'll give us, get rid of that radical, like I said, so that'll give us 3x plus 4. Oops, don't need parentheses around that. And here we have the 2 plus radical 2x minus 4 times 2 minus radical 2x minus 4. So we go to do the FOIL here, so I'm going to write this one out. So, of course, 2 times 2 is 4. And then 2 times negative square root of 2x minus 4 would just be negative 2 radical 2x minus 4. And then we get the same thing here. We get radical 2x minus 4 times... Why did I write a plus? God dang it. I make a lot of dumb mistakes. So that should definitely be a plus sign right here. So that should be a plus. Sorry about that. So as I go do this one, I get positive 2 times 2x minus 4. And then, all right, this last one. So, radical times itself is just the expression. So we would just get, like the square root of 5 times the square root of 5 is just 5. So just, the radicals cancel each other. And so we're just left with that thing that's underneath the radical. So we just end up with that expression, 2x minus 4. And 3x plus 4 equals that. So what I notice about this is a pretty, this problem will be pretty complex, as I still have some terms with radicals in them. So I'm going to get all this stuff that doesn't have radicals on it away to this side. And so I'm going to subtract 4. I'm going to subtract 2x, and then I'm going to add 4. Well, those are going to cancel, so just get rid of that. So I'm just going to end up subtracting 2x to the side. Then here, these two, I'm going to add, so that's going to give me 4 of those things. I have 2 and 2, so that's just going to be 4 of them. That's going to be equal to, what do we get over here? So we got 3x minus 2x, which would be x, and then the plus 4 is dropping down. So from here, give me that. And so now I want to square both sides. I could divide by 4 first, but I think it actually would make the problem harder if I do that. So I'm going to go ahead and square both sides because I want to get rid of that radical. And so, of course, x plus 4 times x plus 4 that would be x squared plus 8x plus 16. That's going to be equal to, so if we think about how this is going to work, like 4 times just this like square root of 2 squared. We've done this before. If we think that would be 4 square roots of 2 times 4 square roots of 2, which could be the same thing as 4 times square root of 2 times square root of 2. That would give me 16, and then these two would combine to give me a 2. Square root of 2 times square root of 2 being 2. That would give me like 32. So as I go to, think about this before, that times itself. So the 4 and the 4 would give me 16. And then the 2x minus 4 times square root of 2x minus 4 times square root of 2x minus 4 would just be 2x minus 4. Alright, so we're start writing smaller. So it's going to be 32x minus 64. Alright, just like before, I want to move everything to one side so I can get 0. So I'm going to subtract 32x from that. So x squared, 8 minus 32 would be negative 24x's. And then I want to add 64 to both sides. That would be 80. So I want factors of 80 that add to be negative 24 would be negative 20 and negative 4. And that means that x would be 20 and x would be 4. All right, just enough room. So let's go check those. Get rid of this junk. Make sure I do a better job of plugging in the x's this time. So checking 20 first, square root 3 times 20 plus 4 minus 2 times 20 minus 4 is supposed to be 2. So 3 times 20 plus 4 would be 64. 2 times 20 minus 4 would be 36. That's supposed to be 2. And that would be 8 minus 6 equals 2. Sure does. So 20 works. Checking 4. So 3 times 4 minus plus 4 minus 2 times 4 minus 4 equals 2. 3 times 4 plus 4 is 12 plus 4 is 16. And 2 times 4 is 8 minus 4 is 4. So 4 minus 2 equals 2. Sure does. So they both work. Yay! Alright, moving on to the next page. It's not too bad. That was probably the worst problem we're going to run into, so I think there was probably just like one of those on your homework, so just something to try. And so definitely not a big deal. So we got a root that we're just going to isolate of the review. I'm going to go ahead and write myself a little reminder so I don't forget to tell you guys them, and you guys will be sure to watch the whole. Oh, jokes. Good thing I wrote that there because I had forgotten. Let's see. Well, I've got this joke about macaroni, but it's too cheesy. All right, so seriously. What is Jose Cuervo's favorite book? Tequila Mockingbird. Ooh, yeah. All right. Let's see. Same problem as the first one. We pretty isolated, so no biggie there. So we just need to raise each side to a power that's going to cancel the root. So since we're with a cube root, we're going to cube both sides. So, and since cubes and cube roots cancel, so like that's going to cancel that. That's going to cancel that. So we're just left with 2x squared plus 1 is going to equal 1 minus x. So I'm just going to move everything to the side where the higher power is. So I'm going to subtract 1, add x, subtract 1, add x. So that's going to give me 2x squared plus x equals 0. Some easy factoring, both have an x, so x. 2x plus 1 equals 0, and then set x equal to 0. 2x plus 1 equals 0, so subtracting 1 divided by 2, so negative 1/2. All right, not too bad. Let's go and check those guys. So cube root of 2 times 0 squared plus 1 equals cube root of 1 minus 0. So 2 times 0 squared plus 1, that's a cube root of 1. 1 minus 0, cube root of 1. Cube root of 1 does equal cube root of 1. Boom. 0 works. Checking negative 1/2. So 3 cube root 2 times negative 1/2 squared plus 1 equals cube root 1 minus negative 1/2. All right, so make sure we're doing our order operations. So we got cube 1/2 squared, which is 1/4. 2 times 1/4 is 1/2. So I have the cube root of 1/2 plus 1 equals cube root. Well, 1 minus negative 1/2 would be 1 plus 1/2. And I'm sure the cube root of 1.5 would be equal to the cube root of 1.5. Whatever that is, it equals itself, so they both work. All right, easy peasy. Oh, man. Let's see. All right, and then last problem. So this one's a little different. We got that rational exponent. Remember that rational exponents are just a different way of writing radicals. That was something we talked about in chapter R, just a reminder. So let's see, just quick reminder about what that means. Like x to the 1/2 power equals the square root of x, so like that. So we just, like that. X to the 5 or 4/5 would be equal to the 5th root of x to the 4th, or the 5th root of x, to the 4th. The same thing. So radicals and rational exponents are just different ways of writing things, the same thing. So yeah. But we're going to isolate the term with the power in it. So what we mean by that is we're going to get this by itself. Really, we want to get this by itself. And so we're going to get rid of the 4, we're going to get rid of the 5 in the appropriate order. So we're going to get rid of that 5 first. This is definitely one of the areas where I've seen students make mistakes in the past. They just try to get rid of the exponent first. That does not work. That will equal 16. Then we're going to divide by 4. And so then we go x to the 3 halves equals 4. Then we're going to raise both sides to a power that will eliminate that power that we have. And, well, if I want to get rid of the 3 halves, I want to multiply by, I would multiply it by 2/3. So we're going to raise both sides to the 2/3 power. And so, why that works is because these will multiply, and so that would just be, become 1. And so we'd x to the first there, which, of course is just x, equals 4 to the 2/3 power. And so, if we want to try to figure out what that was equal to, we could say, well, that's 4, and then the denominator is the index, cube root of 4 squared. Well, the cube root of 4 is not a nice number, and so squaring it is not going to make it any nicer. So there's really nothing for us to do there as far as figuring out what that's equal to. We can plug it in a calculator and find out some funky decimal, but really no point in doing that. So because that's not going to take us anywhere, I would just backtrack and say, this here is my answer that I'm going to use to check. So I'm going to bring that up here and say we're going to have 4 times, 4 to the 2/3, and that's raised to the 3 halves. So what I've done there is just, plugging it back in up here. So I took the x and replaced it with 4 to the 2/3. So make sure I have the 4 still in the 3 halves power that we see up here, and then the plus 5 equals 21. And again, don't solve this left side. We want to simplify it. And so the first thing I do, simplifying, we should call PEMDAS. So I want to do those exponents first. So just like I said earlier, this is going to multiply and become 1. So we have 4 times 4 to the first, so 4, plus 5 is supposed to be 21. And 16 plus 5 is 21. And of course 21 equals 21. So check. So there's our solution, 4 to the 2/3 power. There we see it. So pretty easy lesson, pretty short lesson. Just be careful that problems like that second one. Here's your homework down here at the bottom of this. And I hope you guys enjoy the rest of your Monday and had good weekends and all that fun stuff. And I'll see you Tuesday. Take care.